All right, we're going to talk about gas giants today and a few weird riddles associated with them. Um, and you name the planets, that's an important thing. Make sure you can do that by now. Rotation, revolution, we'll talk about. And why the gas giants are so big and why they are where they are. And as you should be aware by now, the red star means that is what I want to see in your notes. And let's go ahead and get started. First things first, revolution. All planets revolve around the sun in the same direction. All right, so the word revolution means orbiting around the sun. Okay, one revolution means one full complete orbit. Now, rotation is different. Rotation means spinning on the axis. Each planet spins on its axis, and each planet's actually tilted in certain different ways. Uranus is tilted almost 98 degrees, and the only one that's not spinning counterclockwise, if you're looking at it from the North Pole, is Venus. Venus is a little weird. It's spinning the opposite direction. We think it must have collided with something, and then its rotation had changed, right? So the sun will rise in the west and send the east for Venus, but east to west for everywhere else. Now, the gas giants, the biggest planets. Jupiter is the fifth largest, or is the fifth planet from the sun, but is by far the largest planet. And it has this little red spot. It's a hurricane that's, you can fit two Earths inside of this hurricane, and it's been going on for 400 years. Galileo saw this 400 years ago, about, so pretty wild. All right, there's Jupiter. Saturn is also the second largest, and it's the sixth out from the sun. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn has this beautiful ring system right here. We have Uranus, which is tilted almost 90 degrees on its side, has a faint ring system. And then we have Neptune, which is our eighth planet from the sun. It's a super cold planet as well, with temperatures at negative 340 degrees. So, really, what we want to solve today is why are these gas giants here so big? But first, let's see if we can match up the letters to the numbers. Can you do it? Well, number one is right here. That's C, Venus. Number two, Jupiter, is F. Number three is A, the Sun. Number four is H, Uranus. Number five, the smallest and closest to the Sun, Mercury, but remember, not the hottest. Six is Earth right here at letter D. Seven, the furthest one out, that's Neptune right here. We have Mars, which is right next to Earth. It's the smaller one because remember, Venus is almost the same size as Earth, and then Mars is colder as well. And then Saturn is easy to spot because it has beautiful rings. Now, why are the gas giants all out here? How come Jupiter isn't right next to Mercury or Venus? And why are they so big? That's our goal. That's what we want to solve today. Well, there's a few important things to note. I want you to see if you can remember these steps. And I'm going to play this right here, right? It's just our little animation. Here, the nebula, remember, it's 90% uh, gas or more. Okay, so let's play this. So all of this is gas, all right? So the nebula collapses and it spins into this flat disk, right? That's also why the Kuiper belt is a flat disk, basically, but the Oort cloud is not. Then fusion happens when the core reaches 10 million degrees Celsius. Now watch what happens. It produces light and turns hydrogen into helium, but bam, solar wind is created, which is pushing all of these gases out. But it's not pushing the little rocks in here. Because remember, the nebula is mostly gas, but also has a little bit of rock and metal. And the rock and metal is harder to move. Okay, now there's a word for having some resistance to movement. Okay, the gases are easy to move, right? They get pushed outside to the outer edge of the solar system quite easily. So, solar wind is the key here. And there's this thing called inertia. I want us to check this video out on your own time. I may even assign this as another ed puzzle, but an object's tendency of resistance to change in its state of motion. So if we have rock or a gas floating, right? And we turn on the fan, which one is going to be blown away? Well, it's the gases, right? Because a rock has more inertia, right? Think of it in terms of heavier or having more mass. It's harder to move if it has more mass, okay? So solar wind was able to push the gases outside of what do you call it? The asteroid belt, but it was not able to push the bits of rock outside of the asteroid belt. So when fusion began, solar wind pushed the gases away, but not the heavier rock or metal. And that's why gas giants are further from the sun, because all the gases were pushed away. And guess what? Gas giants are made of gases, right? So why are they so big? Why are they gigantic? Well, remember, our nebula is 90% gas or more, and our solar system began as a nebula, right? So there's just more gases in our solar system. So the gas giants, there's more gases than there are rocks. So things that are made of gases will be larger because there's more gas, right? And that's why. That is our answer to that simple question. So just a review here. This was a real quick lesson with lots to review, but please don't hesitate to ask me questions.